Welcome to GetChemistryHelp.com. My name is Dr. Kent, and in this video we're going to discuss the concept of limiting reactants. Now, if you haven't yet watched our video lesson on stoichiometry, I suggest you check that out first, as that'll be very helpful for this. Now, a limiting reactant problem is a reaction in which you have too much of some reactants and not enough of another reactant. So the best way to probably illustrate this is just by using a simple analogy. So let's say we're going to make cheese sandwiches. We can imagine that our reaction is one slice of cheese reacts with two slices of bread to produce one cheese sandwich. So our stoichiometric ratio is 1 to 2 to 1. Now again, just as in a chemical reaction, the ratio is particles or pieces. So our particles could be molecules, our particles could be moles, or particles could just be pieces of cheese and bread. So one slice of cheese reacts with two slices of bread to make one cheese sandwich. Well, does that same ratio work for mass? In other words, could I have a 1 to 2 to 1 mass ratio? Could I say for every 1 pound of cheese, it reacts with 2 pounds of bread to make 1 pound of sandwiches? Of course not. The stoichiometric ratio is always pieces or particles, not mass. Okay, so let's say then, for example, we didn't have the exact 1 to 2 ratio of reactants. So we have 3 slices of cheese and 8 slices of bread. Okay, well, how many cheese sandwiches could we make? Well, for every 1 slice of cheese, it takes 2 slices of bread. So I use up 1 slice of cheese and 2 slices of bread to make 1 sandwich. And then I use up another slice of cheese and 2 more slices of bread, make a second sandwich. Then I use a third slice of cheese and 2 more slices of bread to make a third sandwich. Okay, so we made 3 sandwiches. Well, notice we still have some bread left, even though we used up all of the cheese. Okay, so what reactant did we have an excess of? Well, we had more than enough of the bread. So bread is called the excess reactant. Again, the reactant you have more than you need, that's the excess reactant. What reactant did we run out of that limited our sandwich production? Well, our 3 slices of cheese ran out first, and that limited us to only 3 sandwiches. So therefore, cheese is called the limiting reactant, because the 3 slices of cheese limited us to only 3 sandwiches. So the limiting reactant is always the one that's completely consumed or completely used up. And it's called that because, again, it limits how much product we can make. So in our example, the cheese ran out first. So those 3 slices of cheese limited us to making only 3 cheese sandwiches. Therefore, cheese was the limiting reactant. Well, let's do an example now with chemistry. So in our reaction here, they say, how many moles of water can we make from 6 moles of hydrogen and 4 moles of oxygen? Okay, so if we mix together 6 moles of hydrogen and 4 moles of oxygen, how many moles of water can we make? Well, we're going to do the calculation twice. First, I'm going to take 6 moles of hydrogen, see how much water that lets me make. Then I'm going to take 4 moles of oxygen, see how much water that lets me make. So let's just try it out. So 6 moles of hydrogen. Okay, well, I'm trying to relate moles of hydrogen to moles of water. Well, I see from the stoichiometric ratio that for every 2 moles of hydrogen, I produce 2 moles of water. So I'll put 2 moles of hydrogen on the bottom and 2 moles of water on the top. Okay, so I can work that out. And that shows me that for every 6 moles of hydrogen, I can produce 6 moles of water. Okay, well, how about the 4 moles of oxygen? Well, 4 moles of oxygen, and I want to relate that to water. So what's the ratio between oxygen and water? Well, for every 1 mole of oxygen, I can produce 2 moles of water. So I need moles of oxygen on the bottom. So 1 mole oxygen, 2 moles water. So we cross that out. So now that lets me make 8 moles of water. Okay, so our question is, well, how much water would we actually make? Would I make 6 moles of water? Would I make 8 moles of water? Or would I perhaps add them together and make 14? Well, we always make whatever was the smallest number. So in our case, we're going to make 6 moles of water. Again, if you think back to our cheese sandwich analogy, I had enough cheese to make 3 sandwiches. I had enough bread to make 4 sandwiches, but I had to make whatever was the smaller amount, which was 3. So what was the limiting reactant? Well, the hydrogen here limited me to making only 6 moles of water. So what was the excess reactant then? Well, there was plenty of oxygen to keep going and make up to 8 moles of water. So oxygen is the excess reactant. So again, the 6 moles of hydrogen limited me to making only 6 moles of water. But there was enough oxygen to make 8 moles of water. So hydrogen was my limiting reactant and oxygen was my excess reactant. But you'll notice though here that even though there was more moles of hydrogen, that was still the limiting reactant. So you can't just look at the initial amount of the reactants. You have to actually solve it in terms of one of the products to see which one actually limits. So even though there was more moles of hydrogen than oxygen, hydrogen still wound up being the limiting reactant. And oxygen, which there was less of, actually wound up being the excess reactant. Okay, well, as we saw in our stoichiometry problems, of course we don't normally do reactions with moles, we do them with mass. So let's just try an example here using aluminum and iron 3 oxide. So this reaction, by the way, is actually called the thermite reaction. It's kind of an interesting reaction in that the reaction gets extremely hot. In fact, it gets so hot that it actually makes liquid or molten iron. This is a reaction they'll actually use on the railroad sometimes because they can take these 2 powders, mix them together, give them a little spark, and it makes molten iron, which they can use to weld together the steel railroad ties. Okay, so in our reaction, if I have 113 grams of aluminum and 279 grams of iron 3 oxide, well, how many grams of iron could I make? Okay, well, we're going to turn 113 grams of aluminum into iron and 279 grams of iron 3 oxide into iron, and we'll see whichever one produces the least amount. That must be the amount that we actually make. So let's just try this. So 113 grams of aluminum. So I have mass of aluminum, and of course I always need to turn the mass into moles because these coefficients, 2 to 1 to 1 to 2, that's the mole ratio. So I turn mass into mole with my old friend molar mass. So I look at my periodic table. And if you don't have a copy handy, you can always go to getchemistryhelp.com and print one out. But the molar mass of aluminum is 26.98 grams per mole of aluminum. So I get rid of my grams of aluminum. Okay, well, I'm trying to relate moles of aluminum into iron, it says. So for every 2 moles of aluminum, I produce 2 moles of iron. So moles of aluminum are on top here. So I got to put moles of aluminum on the bottom in order for it to cancel. So 2 moles of aluminum produces 2 moles of iron. Okay, now I'm in moles of iron, but I want the mass of iron. So moles to mass, we use the molar mass. So we find iron on the periodic table, and that's 55.85 grams per mole of iron. Okay, so moles of iron cancels. So we can put that in our calculator. Okay, so we have 3 sig figs, 4 sig figs. The mole ratio is always exact, and then 4 sig figs. So my answer must have 3. So 113 grams of aluminum lets me produce 234 grams of iron. Well, how about the 279 grams of iron 3 oxide? Well, we'll do a similar calculation for that. So 279 grams iron 3 oxide. We're going to have mass, and I always need to get it into moles to use the stoichiometric ratio here. So we find the molar mass of iron 3 oxide. So we add up 2 irons, 3 oxygens, and I got 159.70 grams. That's the mass of a mole of iron 3 oxide. Okay, so grams iron 3 oxide cancels. Now I have moles. Again, I'm trying to relate iron 3 oxide to iron. So for every 1 mole of iron 3 oxide, I produce 2 moles of iron. So 1 mole iron 3 oxide produces 2 moles of iron. So moles of iron 3 oxide cancels. Well, again, the molar mass is 55.85 grams per 1 mole of iron. So moles of iron cancels, And this again is 3 sig figs, 5 sig figs, exact, and 4 sig figs. So the answer must have 3, so 195 grams of iron. Okay, well again, the question is, how much iron do I make? Do I make 234 grams? Do I make 195 grams? Or do I make some combination? Well, we always pick whichever one is the least amount. So in our case, we would make 195 grams of iron. Okay, then which reactant was the limiting reactant? Well, whichever reactant gave me that amount. So in our case, the iron 3 oxide was the one that limited us to only 195 grams of iron. So iron 3 oxide, this is the limiting reactant, which means aluminum had to be the excess reactant. Because again, there was enough aluminum to keep going and make 234 grams of iron. So we had more than enough aluminum, but the iron 3 oxide is what ran out and limited us to only 195 grams.